Hello, YouTube. I am Carrie Sandra with Alpenglow Industries, and welcome to the Wednesday Solder Sesh. Today, we are putting together a Dreamweaver kit. Here, let's give you a better view. Look at that. So this is the entire kit, and it's a little digital synth. We got like 4 different notes. We got two like little rotary pots that adjust the duration and spacing, and then like on-off switches and stuff like that. It's all controlled by an Atmega 328. I don't believe that there's any real analog conversion going on, so I think it's just like PWM kind of square waved, very bleep bloop based, but just a super fun little kit that like makes some noise. So like, let's make some noise. Awesome. So these are all of the kit components. So these are all of the rotary pots that you see. Hello, Alfred. How's it going? And then these are all of the little switches. So you push these to actually play the notes. The rotary pots for each note, I believe, is to kind of like tune the note. And then we have like the speaker and the Atmega chip, also with a socket, which is quite nice. On-off switch, a little power converter, battery wires, and also a 9-volt battery comes with the kit, which is quite nice. Didn't have to make one of those, or didn't have to buy one of those. And some LEDs. And yeah, that's it. So we can get going. Go do that there. So with this kit, there's a nice little QR code that you can scan to get instructions, which I have done. So I am going to try to RTFM, and so these are the instructions. Step 1 is to locate the 100 ohm resistor, solder that in, and then step 2 is to take the 1K resistors and solder those in. So this guy, our single lone resistor, I am supposing is our 100K, and then we have like a whole bunch of resistors here, which are very likely the 100 ohm, and then the 1K. And not to be confused with this guy, which is an inductor. Oh, interesting. We are getting some weird blips on the screen, huh? We have a new setup today. We're trying new things. So we're using like a little HDMI switch here with our video, which I think might maybe be causing those blips. But the reason that we're using an HDMI switch is so that we could, let's see, what should we put on the screen here? Let's try to do the push button on the screen. Yeah. So we have the inspection scope set up so that we can get some really good close-up shots of things. So anyway, it's kind of cool because it allows us to super easily switch between our workbench and the inspection scope, but we might be having some technical difficulties. So we'll see. It is a work in progress. We're tweaking stuff every time to try to bring you better quality and everything. Let's see. So 100K resistor while the thing is so close up. Yeah. Hello, Jason. How's it going? Yeah, the scope I think is on like, I don't know, about 25x at least right now, I think. But yeah, it's a really nice digital inspection scope that I might have bought years ago at a trade show after drinking some booze. It happens. I was just looking for an excuse, really. Yeah, my original thought with that scope was I'll put this in here. So I'm putting the 100 ohm resistor in right now. The original thought with that scope was that that I would be able to use it for soldering, but it is very, very difficult to not have stereo vision when you're soldering. So yeah, it's just like the lack of depth perception is kind of disconcerting. And I'm sure I could probably get used to it and it wouldn't be that big of a deal, but yeah, I haven't spent time trying to do that yet. Today, ooh, my soldering iron is off. I think it went to sleep. So today I'm using this different soldering iron too. This is a very inexpensive $30 kind of entry-level soldering iron. This one I got from Adafruit, and it's pretty nice because it goes all the way up to lead-free solder temperatures, and it has like these Hako style tips. This one is like a little bit of a blunter tip, which is kind of nice. So yeah, just kind of trying this out. It's not what I would solder with every day because it's like a little bit bulkier here with the handle, and you have, the LCD and stuff that's like, it's kind of just like a little bit, I don't know, it's a little bit clunkier. But I think if you're just getting started with soldering and, you want to try it out, you don't quite know if it's for you yet. This is a 65-watt iron, so it can pump out like a fair bit of heat, and it's like very nice quality for $30. So yeah, so using it today, seeing how I like it. All right. And also using a little bit of different solder today. If I can get this there. It's just like a, tiny thing of Kester lead-free solder. So Kester is probably my favorite brand of solder. They make nice quality stuff. This is tin, like 97, essentially 96.5% tin, 3% silver, 0.5% copper, and rosin core. And this is only like, this little thing is like only $5. So going with kind of inexpensive getting started soldering stuff. And part of the reason I'm doing that is because we just actually finished making a Learn to Solder video, and we'll probably be releasing that next week. I'm kind of excited about it. I know that there are a whole bunch of, Learn to Solder videos out there. A lot of people have done it. That's great. Can't have too many. I think, like, I don't know, there are just some things that I like to point out and stuff that I haven't really seen pointed out before about like kind of how to hold your iron, how to hold your board, that kind of stuff. So yeah, so made a video, pointed that stuff out, and excited to finally, have that out in the world next week. So finishing up just a little bit of stuff on it. All right, so now I'm going to put the 1K resistors in. So I soldered in the 100 ohm resistor. That one is marked on the kit. All the other resistors, they're not like marked as far as value go, but that's okay because they're all the same value. So we're just gonna like bend them and put them in. Yeah, so what have you guys been soldering this week or making this week or building or whatever? Anything fun and interesting? Maybe not. Takes time to type. Just like putting those guys in. There aren't too many of them, only I think 12. But yeah, what else is going on? Something that Robin and I have been talking about today, and Robin is here. She can say hi if she wants to, but she doesn't have to. the disembodied hand wave. she's working the screens and the and making me aware of comments and stuff, which is super helpful. But yeah, so something that we've been kind of noodling about today is that she just graduated from the scooter to the boot. So she recently had foot surgery, so she's been, you know, a little bit gimpy since then. And we're going to, you know, we have all these LED strips, these scrap LED strips. So we're going to light up the boot. Haha. All right, Alfred. Oh, I was gonna solder the PS I Hate You kit tonight. Nice. Well, that is okay. You're totally allowed to be exhausted from work, Alfred, and you know, you don't have to solder anything if you don't want to. Watching other people solder is totally fine as well.
But the PS I Hate You kit is so relaxing.
Yes, it is so relaxing as the angles are so terrible and odd and nothing is straight. Oh, funny. Jason's, getting the new Fibonacci 64 prototype PCBs and parts. Yes, I'm excited about that. Your photos and screenshots of that have looked super cool. For those of you who haven't caught that, Jason is working on another version of his Fibonacci boards, this time with the LEDs starting small in the middle and increasing in size towards the outside. And I think that that is going to look super duper cool. You need to see progress pics for the light up boot. Yeah.
We'll put it up on Hackaday.
Yes, definitely. So like the first things we're just in the early planning stages, gathering parts and, you know, figuring out what else we need. But like the first thing that we were thinking about was like, okay, well, what do we want it to do and how do we want to power it and stuff? And here's a question for you guys. Is there like an Arduino compatible board that has both a like a motion sensor, like a 9 DOF, or even actually just an accelerometer would be totally fine, and has a boost converter with 5-volt output so that you can power it off of one lithium-ion battery and provide 5 volts for all of the LEDs. I didn't see one like an Arduino board that has a built-in boost converter, although there are certainly more Arduino boards out there than what I know about. There are a lot of them that have, you know, some sort of like 9 DOF or acceleration sensing on them. So what we are thinking of doing right now is, since we had some circuit playgrounds, and they have a ton of stuff on them. So we had some circuit playgrounds, and there's a feather that does. Cool, that might be cool. Yeah, so the circuit playground is pretty cool. It has a ton of stuff on it, and I found that I just happened to have in, you know, my one of my boxes of tricks, a little boost converter from Pololu that's just like a tiny board. So we were thinking of just, you know, splicing that in there essentially and using that for LED power. And yeah, do I have it handy? That would be a good one to put under the microscope. Let me see if I can grab the thing. So let's see. Pachink. Workbench. Where are you? Where are you, board? You are so tiny. Yeah. So this is the tiny little boost converter board. It's kind of ridiculous how small it is. Yeah, that's a SOT 23.5 part on it. Hard to do this looking at the camera, but yeah, right there is the SOT 23.5 part. So you can get a sense for, interesting. Okay. So Adafruit Feather NRF 52840 cents. Cool. I'll have to look that one up. I'm going to write that down right now so that I don't lose it. Well, I guess this will be on the stream later that I can look it up. So yeah, there we go. Cool. No problem, Jason. See you later, and thanks for that. Thanks for that recommendation. I will definitely look it up. Yeah, we're trying to keep the whole thing pretty small because she has like a good, like tiny pocket that's back by her heel. So there's like a little bit of dead space there between the edge of the boot and her heel. So, we could totally shove like a small board and lithium ion battery in there, and we'll do a really good job so that it doesn't catch on fire and burn the crap out of her foot and, all that kind of stuff. But, no risk, no reward. Would that count for workers' comp? Probably would. Don't worry, Alpenglue Industries has paid insurance. We're all good.
It'd be a good story.
It would be a good story. So I did this thing for work, and then my foot caught on fire. But yes, so that is what we are conniving on. So yeah, essentially the light up sneaker instead, but boot instead. And there's all sorts of other stuff on there too, like other sensors on the circuit playground. And I mean, it has LEDs on it too, of course. But I think that there's like a temperature sensor there. I don't know if there's like an ambient light sensor on it too. But yeah, there might be some cool things that we can do with like different modes or making the color patterns reactive to different things. That might be kind of neat. So yeah, all right. Doing the last 4 LEDs. What I was doing right there was I was just like taking my finger underneath the board and feeling where the leads were and just kind of like bending them out so that when I turn the board upside down, they're like nicely splayed like that and don't fall out. I have this soldering iron set to 450 C right now, and that seems to be a pretty good temperature. Things are flowing very nicely, and this like slightly blunt, I would call it, like it's not like a super big screwdriver tip, but it's, just like one of those slightly blunt screwdriver tips. It conducts heat super well, so everything is just kind of flowing nicely, soldering well. The Kester solder is also doing nice. Right. I think, what do we got? What is my process for bending leads? Oh, okay, yeah, once they're in the board. Yes, I tend to bend them outwards as well. It depends a little bit. Sometimes I feel like it can be perhaps better to bend them inwards, because if you have 2 patterns that are very close to each other, let's see, this board is not a good example because they have not put patterns that are close to each other. But like if you had, let's see, a resistor, like if these 2 were closer together here, if you had like resistor here, and then the second one was right here, and so these 2 pads were close to each other, then if you bend them both outwards, you might cause the leads of like this one and, our imaginary resistor that's like right next to it there, they might be kind of close together, and, you increase the chance of bridging. So like in cases like that, bending the leads inward would be better because you're bending the leads away from each other. But that said, it's easier for me to feel where the leads are underneath and just bend them outwards with my fingers instead of the other way around. So so that's why I just tend to do them outwards. what I like about all of these kits that I've done so far, which is not necessarily what I have done on my kits, and so I might be taking a little bit of a note from this for future ones. But what I like, soldering the inductor right now, right there. It's a nice kind of teal color. I like it. Yeah, so the nice thing about these is that the pattern has been designed so that no real special bending, no special pre-bending is required. You basically just like, of course now I've bent all the components, but you basically just take the resistor, you know, bend it by hand to either side, bend the leads down to either side, and just put it right in. And that's nice because it just goes right in and it's easy to solder. Others, there might be reasons to have different spacing so that you would have to like bend the leads out here. I think the pattern that I used on like the I voted boards is just like a little bit wider. So, you know, it's still not that bad. Like you can just, you know, basically just put the leads in and shove the resistor in. But it is like a little bit wider. So yeah, I might go with this, with this style of pattern for things in the future. I do have like, yeah, so old school boards would often have leads bent, like would also often have, you know, different kinds of spacing. Hey Dan, how's it going? It's good to see you. So yeah, old style boards would generally have different spacing because you might be kind of using the lead to get a trace to a different point of the board. Basically, instead of like routing the trace on the board, you would skip over traces or something with the lead. So there are reasons to make make different bend lengths. And there are these really nice little bend guides that, you know, you put the resistor in the middle and then bend the leads across it, and you can make very accurate different lengths that way. So, you know, sometimes I'll do that, but generally I only use those for solderless breadboards. Hello, Saguaro Links. How's it going? So Dan and Swara, wondering if you guys have been making anything this week or working on anything. I'm doing the 2 capacitors next. I probably should be following the directions. Let me see if there's anything that is particularly step dependent. Oh, yep, did the green inductor. Oh, nope, 2 small capacitors. Look at that. I am right on track. Almost like I read the instructions. So yeah, let me know what you guys have been working on, if anything, or thinking about working on. You know, projects that are only in your mind totally count too. Oh man, I wonder, does the Circuit Playground have a speaker on it? Like, could we make you make robot noises when you walk with the boot on, as well as light up LED stuff?
That would be super cool.
I must say, I kind of got that idea from some robot boot slippers that I have.
Robot boot slippers?
Yeah. They're these slippers that I got them as part of a White Elephant gift exchange, the same one that I made the F Unicorn for originally. And yeah, they're like these giant robot, like they're like wearing pillows on your feet. They're huge, and I think that they were like maybe a Sharper Image thing or something. I don't know. One of those places that sells like a bunch of funny kind of tech stuff. Noises? Yeah. So every time you walk in them, it's like ka-choom, ka-choom, ka-choom. They're very great for just like tromping around the house and pretending you're a robot.
Cool. It does have a speaker.
Ah, yes, it does have a speaker. Nice. That's what you use for the heart button. Excellent. Cool. Oh, you finished the Fibonacci kit, Swarlinks. Excellent. Awesome. Oh, work schmirk. Ooh, making some more Mars helicopter rover badges. Oh, nice. Very cool. Getting distributors. Love it. Yeah, I was thinking so I received the your perseverance badge like right around the time that we moved to the shop, and so I'm like slowly digging stuff out of the black hole that everything disappeared into, and so I now have like a little plastic bin full of the badges, and I need to get some sort of like cool badge display up and going. But I was thinking I need to order one of your oh God, why is my brain farting on the name? The little helicopter, the companion helicopter that goes with it.
Mars helicopter.
Yeah, the Mars helicopter. But it has a name that I am blanking on right now. Begins with an I. It's not infinity. I don't know. Maybe more beer will help. All right. What do we want to solder after the capacitors? I think, okay, it says to solder the 5-volt regulator next. So we could do that. I suppose. We'll follow the instructions. Why not? So that goes here in the U2 position. Ingenuity. Thank you. Yes. That is indeed. I knew it began with an I. So yeah, let's see. Go up here. So this guy is going to go there. Yeah, badge display. So that's a good topic. 7+ flights now. Holy crap, that is cool. And my poison of choice, I have been working my way very slowly, fortunately, because you can't work your way too quickly through the work beer fridge. Well, I mean you can, but it's not very good for like actually being productive. So just a little note right now. So I'm bending these leads because this pattern is sort of a 90-degree one. And there are these little, so there are fat sections of the leads. Well, use the scope. Look at that. Right. So you can see that there's a fat section of the leads near the top, and then they neck down. And so we're going to bend them like right at that point where the fat goes to skinny. And because that's about where it should be for the holes to line up. I have a bunch of different pliers that have smooth sides. These kind of have this nice fat tip, so they're not real needle nose or anything, so they're nice and burly, and you can bend a bunch of leads all at once pretty well. So I'm just going to do that. Boop. Where the fat goes to skinny. Yeah. There's probably a better way that I could have said that, but live YouTube words sometimes don't work. It's not the beer, I swear. The beer helps. So yes, I'm working my way through a Sierra Nevada 6-pack because it's not too boozy, so that I won't do anything really stupid, hopefully. Wide to thin section of possible weak spot. Yeah, although honestly, these are pretty big, burly leads. And once they're bent, you're only going to bend them once. You're not going to put them back and forth. And once they're bent, they're going to stay in place, and they're going to the legs are then going to be soldered in place. So I'm not too worried. It's not like we're putting stress on that chip after the leads are bent. It's not being used for anything like that needs to have structural integrity. I'm kind of going to do this one outside of the vise because I'm going to hold it on the back side. You can see that there's like a little bit of wiggle room here, and what I want to do is I want the hole in the in this heat sink area of the chip to line up with the hole in the circuit board. And that's so that is I don't think that they're really using the heat sink capability of this. If they were, it would probably be exposed copper underneath. So you would have, oh, thank you. Thank you that my bend looks perfect. I try. Yeah, there would be exposed copper underneath if you really wanted the heat to transfer well. And then you could even like solder it down if you wanted really, really good heat sinking. But like this is basically just converting 9 volts to 5 volts. This is all probably pretty low power. So, you know, it's probably not wasting that much power. So I'm just going to hold it. I'm going to like line up the hole here, flip it over. All right. See ya, Alfred. Sorry, your brain is fried. Next time. And then, so what I do right now is I get a ball of solder on the end of my iron and I tack it down. So I just like, ow, make a super crappy solder joint. The heat does transfer through the board in case you're wondering. So I make a super crappy cold solder joint there that really just serves to kind of temporarily hold it in place. So now I can put it in the vise and I will then solder the other 2. So my crappy one is in the middle. So I'm going to solder the top and the bottom. So top and bottom. And then I just go over the middle and I add a little bit of solder because solder contains flux and flux will clean up that joint nicely. And there we go. And I am going to clip these guys off. Ka-chow. And go on to the next one. Interesting. Can you scroll up a little bit? Yeah, I want to see the comment about dab of glue on the MOSFET. Oh yeah. Yep. So Dan's pointing out that you know, for something that might actually be more stressed, or if you had something that was going to be moving around a lot, vibrating a lot, whatever, that you could glue the MOSFET down. Typically, you can also just put a screw through here and then, you know, a nut on the back, which I might do. And that's more of a safety thing. Like, I don't know, just in case like this got caught on something when moved or stored or whatever, it couldn't like, you know, accidentally like yoink the chip out or anything like that. Not that it would come out, but it could, you know, bend up and kind of get mangled or something. So yeah, I'll probably find like a little screw and a nut because we have a ton of tiny fasteners around here. And when we're all done, I'll just like cinch that down. All right, what is next? I am going to say either LEDs or push button switches. What's next? Push button switches, momentary buttons. Awesome. Doing these guys next. So these guys might, or might not. These can snap in. They're like little bends to the legs. So if you make your pattern like super well, then you can push them into the board and they'll snap in and they'll stay in place, and then you can flip it upside down and they won't move, which is nice. But this board has not exactly been made that way. The pattern, well, actually, I think they don't snap in, but I think that they will be retained when I flip it upside down. So we'll see. If not, we'll be placing all of these again, but there are only 5 of them, so it's not too bad. Let's see. Yeah, no, they're going to come out. So let's see. The other thing that I'm looking at now is, are they the tallest things on the board at the moment? And they might be, so I could flip it down just on the table maybe. It's going to be kind of tough though, because they're all kind of in the middle of the board. If they were on the edge of the board, that would be better. Okay, so what I'm going to do is I'm just going to do the same thing that you just pretty much saw me do with the voltage regulator. And I'm just going to use my finger here. So I took all of the other ones out right now. And I'm just going to use my finger here to kind of hold it in place, flip it upside down, and then get a ball of solder, let's see, tack it in place here. Crappy solder joint, just enough to keep it there. There we go. So I could go through and do that to all of them, or, but you know, with each one, you run the risk that your crappy solder joint will like break off. So I'm just going to finish soldering this guy and then go on to the next one. And we're just going to do it at the level of the board now, since there's going to be a lot of flipping over back and forth. So solder this one. Solder that one. Solder that guy. Solder that guy. And turn it over. Yeah, it's pretty good. It's pretty much square to the board. So yeah, I'm satisfied with that. Oh, Dan did have one project. Due to Rube Goldberg style accident. Oh no. Oh, Dan, I'm so sorry. That must have been a giant sinking feeling in the stomach the minute that happened. Rube Goldberg style accident, though, man. Oh, I know that feeling. Have definitely done a few things like that myself. So, yep. Again, just like tacking one down. Sometimes, especially with lead-free solder, which you kind of have, flux tends to have like a shorter working time with lead-free solder. Sometimes you need to kind of like do it again, or maybe like tack down two. There we go. 2 ones, 2 leads. And yeah, when I'm doing this, I always go back over and reflow the leads that I did a bad job of tacking down first, because they almost always have, kind of a cold solder joint, because really if you put solder on the iron first and then carry it over to your board, pretty much all the flux is burning off by the time you get the solder to the board, especially with lead-free solder. And even the rosin core lead-free solder just has a pretty short working time. And because also lead-free solder is at higher temperatures, the flux just boils off faster. And so lead-free there is kind of such a thing as lead-free flux. It's not that the flux is lead-free, it's that it is formulated for lead-free solder, and I think has like a higher boiling point. So it has a little bit of a longer working time. But even that solder, it just doesn't really stay fresh on the tip of your iron for very long. And so I always go over joints that I tack down this way. All right. You got to see some TV guts. Yeah, silver lining. Ugh. Yeah. There is always an upside, I suppose. I had a little bit of fun with LCDs this week too, although fortunately it wasn't really me. We had a computer, a Lenovo all-in-one that we got last fall, and the backlight started to go out on the LCD. There was like flickering and a dark vertical spot on it. And so fortunately, I actually paid a whole whopping $46 for 2 years of the extended warranty that covers on-site service calls. And boy, am I glad I did that right now, because man, was it much nicer to have somebody else have to come out and like take apart an entire all-in-one computer just to replace the LCD. However, the corollary to the story is that it's not quite over yet, because so this just happened a few days ago, and computer's working, everything looks good, except that today I went to play a CD, because yes, I just bought a new album CD, new Garbage album just came out, and And so, yeah, it wasn't quite put back together quite right, and the CD tray isn't aligned. And so I pushed the eject button and it's all like, so yeah, then I was like, well, guess they're coming back out and fixing that. So I don't know. Would it have been easier to like fix it myself? I don't know. Kevin, you're late. You're late, Kevin. Were you napping? We're almost done. No, just kidding. We're not almost done. We still have plenty to go, but we're making good progress. We're soldering push button momentary switches in place, tacking down one, and then soldering the rest of the leads is the technique here. Yeah, let's see. So yeah, computer repair. Can you scroll up a little bit? I think I missed like some comments up there. Fibonacci 2 kit. Yeah, reheat and joint. Yeah, totally. Okay, yeah, just looking at your comments about heating stuff up and reflowing the joints, SOAR links. I totally 100% agree with that. Always go over and reflow the ones that I originally did. All right. Let's see. Or someone who knows how to fix one. Yeah. Well, okay, I'm saying CD drive because I was using it to play, well, trying to use it to play a CD, but it's actually a DVD drive, you know. It's 2020. But yeah, I was kind of surprised that like an all-in-one that I got last fall actually came with a no shit like DVD drive. But of course, now I've bought a USB one off of Amazon so that I can like play a CD. But you know, that's all right. $20 gets you one these days, which is pretty great. All right, now can I solder LEDs? I just noticed that I think I lost an LED. I did take this kit out in the shop and had it all out on the bench, and then I put it back together. And so I think somehow in that process, oh, nope. Aha, it rolled underneath the microscope. So cool. We do have 5. Excellent. All right. In the, yay, 5 red LEDs. Oh, I like it. 5 red LEDs will be installed. They're not giving you any options about that. They will be installed. You will install them. All right. So I tend to be terrible with remembering the way that things go when they're like not actually marked. Like you would think by now I would remember if the long one on the LED was like the anode or the cathode and all of that kind of stuff, and which one generally points to ground. But I swear I'm like such a visual person. I like need to see the schematic symbol and then kind of visualize that in my head to you know, kind of to figure out which is the anode and which is the cathode, and I can never remember which one is longer. So what I always do with LED patterns is I line up the flat side, which is generally the cathode. Oh, unless it's not. There are LEDs that are, of course, made backwards, which are super fun, which actually, speaking of the PS I Hate You kit, I was totally intending to put backwards marked LEDs in that kit. But due to a kerfluffle with using 3 volts on a 555 timer and that kind of changing the frequency and the amount of current it was able to outsource, I ended up using some high efficiency LEDs and I could not get them backwards marked, sadly. So, you know, you were saved one little piece of hate in the PS I Hate You kit. Dan remembers getting his first CD burner in high school. It was such a great novelty. Yes, right? Yeah, I remember that, like, oh my God, I can actually like make CDs. Like all of a sudden you could do mixtapes, but CDs. It was very, very cool. All right, so I'm looking at the flat side on this LED, and it's going to be almost impossible to see here. Maybe we can see it with the scope. I don't know. It's going to be hard there too to see, I think, because of the roundness of it. But you can tell that, hang on, I've lost it, that one. So yeah, so the flat side is, you can kind of see how the light is hitting it. Flat side is up right now. So fortunately, there's a flat side denoted in the silk screen here so that I can do just line up flat side to flat side. And since the plus and minus are marked also on the silk screen, I can say, oh yes, the flat side, which is the cathode, is the shorter lead. Choo. There we go. So I think I'm going to put these in. I don't like bending LED leads as much because that, like, if you bend them too much, you can actually like kind of tweak the internal guts and cause them not to work. So I'm pretty gentle about bending LEDs, and sometimes I will bend them like this way. Instead of bending them out, I'll sort of bend them at 90 degrees front and back. So there we go. Just displaying them ever so gently. Which one? Oh, move up. Thank you. Oh. Putting these guys in. And the last one. Yeah, because LEDs tend to not be held in quite as well as resistors when you flip them upside down, you know, they tend to, for me at least, they tend to like not necessarily be quite as straight or lined up and pretty, and I'm kind of okay with that. You could do like the tack down kind of thing that we were doing before if you wanted to. So I'm holding them all over now. Yeah, we'll see. Kind of gently splaying them out. All right, let's see what it looks like from the bottom. Yeah, that's not too bad. They're like, you know, they're not quite like flush to the board, but they're looking pretty good and not too cattywampus. So hopefully they'll stay like that as we solder them in. Cool. You probably burned a garbage album with that thing too. Yeah. So I remember when iTunes very first came out on the computer. I was working at a company, an engineering company that was ridiculously devoted to Apple computers. And, you know, it was just an Apple company. And it was really awful because, you know, this was in the late 90s, and, you know, people were just not making software, not like technical enterprise software for Macs. But anyway, that's what we were forced to use. And so that's, so it was kind of painful, but at least we did get iTunes when it first came out, and before there was any kind of concept of like DRM or anything like that. And so it was awesome because like we made this music server, everybody brought their CDs in and burned all of our CDs, put them all on this music server that anybody could play at any point in time from any computer. And it was awesome. It had so much music on it, and it was a thing of beauty. But, you know, probably not entirely fair to the, well, not entirely fair to the artists, but it's not like the artists. Legality. Yeah. Well, at that point in time there, you know, it was questionable, right? Because digital music was all quite new. Yeah. And that was also in the days of Napster. So right. We were like downloading shit off of Napster, putting it on the, you know, on the hard drive. It was great. Putting it on the music server. Yep. Yes, nice points to remember when designing silk screens to match the component outline and add pluses and minus. And component values. Yeah, for kits for sure. And that's something that I sometimes like that I have to remind myself for kits. It's like, oh yeah, I can actually put the component value here because it's just so different from, designing like a high density surface mount board like for a company or something where you never put any values because you just don't have the room, and you're lucky if you can have enough space for reference designators on there. All right, I think I'm going to do the switch next. Can I do the switch next? The switch. Excellent. LED tech has come a long way. Yeah, Kevin's saying he remembers buying LEDs in the 70s that needed 20 milliamps or more depending on color to get any brightness out of them. Yeah. It's kind of funny that like 20 milliamps is like 20 to 30 milliamps is still seems to be sort of the technical spec point, right? That data sheets are written from, and you hardly ever need that kind of current from like just a normal indicator LED on a board these days. But I think what that leads to is like people who are inexperienced, they sometimes they will actually calculate a pretty low resistor value so that they actually are putting that much current through your LED, and then the LED is like blinding. I remember there were some early like Spark Fun boards that had really freaking bright indicator LEDs on them. It was like, oh my god, geez, where's some tape? Quick, put some tape over that thing. Oh, you've yet to design a PCB. You should do it. It's fun. I don't know. I describe it as like a grown-up game of connect the dots, basically. It's, I don't know, something about doing circuit board layout. There's this very satisfying thing that happens in my brain of being able to like connect everything and, seeing all the colors and making your lines all line up and having very pleasing angles. And yeah, I don't get OCD about it. I don't know what you're talking about.
I feel that way about spreadsheets.
Yeah, the ones on Kevin's. You're right, spreadsheets. Yes, spreadsheets are yeah. I can definitely get into optimizing an Excel spreadsheet mode for sure. But yeah, Kevin's saying that the ones that he's using in his Blinky boards, which you all should check out, Maker Bytes. I don't know if he has them for sale on Tindy right now, but I think he or I maybe can sell you a few of them. Yeah, he has some good little like Blinky boards that are reactive to ambient light. So right now I'm putting this socket in, but it's not quite lining up. So I think I might have to get this closer to my actual eyeballs. Oh, that's because there's a little bent lead. So one of the leads bent over a little bit somewhere in transit or whatever. And yeah, and it's no big deal. This happens regularly all the time. And you can just use your pliers to very gently straighten them out. Now, I feel like that one might be
broken.
Yeah, that one is broken. So yeah, that one was a little too bent over. Oh, sadness. That's okay. We will figure it out. I don't know. I don't think I have very many. I don't think I have any extra chip carriers. But what we're gonna do is we're gonna solder it anyway, and we're just gonna get our iron in there. So we're just gonna get our iron in there and maybe solder it just sort of like as a surface mount connection to the board. Let's see. Oh, I think that'll totally work. And what we can do is from the other side, basically the one that's missing, we're just gonna like fill that hole full of solder, and I think it'll be totally fine. I mean, I could also just like directly mount the chip into the board. That would work as well. If you wanted to be super duper like safe about it, if you were really concerned about the, you know, the reliability of this board, you could like take a bit of wrap wire and like wrap it around there, solder it up there, and like kind of like create your own little lead that would then poke through the hole. But I don't know. I honestly don't think that it's going to be that big of a deal. So we're just going to continue on. Currently learning FreeCAD. Yeah, I am learning KiCad or KiCad. I don't know, however you pronounce it. I don't want to get into the KiCad KiCad wars. But yeah, I'm still learning it. All of my circuit board experience, like the vast majority of mine, has been in professional settings using Altium. So that is my yeah. There we go. So that is my poison, sadly. There are great things about Altium. The bad thing is how much it costs. And then there are also some silly things that are kind of like stupidly hard to do, or information just not organized very intuitively, things like that. But it is quite capable. Key.
Oh.
KiCad. You say KiCad? I have definitely heard both, although I feel like lately I have heard more people say KiCad. All right, just going down, soldering these, back and forth. Oh, that's the one that we're missing. We're just filling the hole with solder. Let's see. Going down. Yeah, so yeah, Dan is saying that he's given some sockets to friends, and sometimes they're like more trouble than they're worth, because you can bend the leads of an IC getting them into the socket. And yes, that is certainly the truth. You do need to have care when inserting them, and generally, I mean, even when putting like a dip IC into a board in the first place, if it's like a brand shiny new chip, the leads tend to be bent out just like a little bit over what the typical pattern is. And so most of the time you actually have to kind of, what I'll do is I'll show this to you when I'm done, but I'll take it and I'll bend the leads in a little bit. Yeah, it might be more beginner friendly to just, you know, stick a dip straight into a board. But what's not beginner friendly is zorching that chip and then having to like unsolder it and resolder it. So yeah, total like 50-50, right? It just totally depends. Yeah, it's a tough call. No perfect answer. So something else that I should just mention is that, of course, you always want to make sure that, you know, chips are always directional. There is a pin 1 that you want to line up with pin 1, and generally that is denoted by, the pin 1 end is denoted by a notch, which is right there. And so there's a notch in the outline on the silk screen, which you line up to the socket that has a notch. And then we will be lining this up. ICs don't really have like notches anymore, but when you get this in the right light, you'll see there's like a slight one right there. And you know, surface mount ones will tend to have like a dot right there, and so this one also has a dot right there denoting pin 1. Some have like a line at one end that denotes the pin 1 end. Pin 1 is always going to be on the left. Well, if they're keeping with any kind of standard, it's always going to be on the left. I don't want to actually say always, because I am sure there is some weird chip out there that will bite you in the ass one day because it's like backwards. But in general, it should be on the left. Yeah.
So is that holder connected?
Yeah, so the holder is now soldered in, and
even where there's no leg?
Yeah, pretty much. Let's see if we can get a better angle on this. What I did was I filled that hole full of solder. Let's see if we can maybe get a microscope view of it. I'll have to kind of try to hold it still. And so let's see. Let me look at it for just a second. 1, 2, 3, 4. It's the fifth one in. 1, 2, 3, 4. Fifth one in. Yeah. So it's basically the one that you can see that's closest to where it says R7.
Oh, cool.
Yeah. And so like it's hard to tell from this side because it's kind of just like sitting flush on the pad right now. The other thing that I could do, let's see if we can do this without melting anything, is we could like try to solder, and this is where a different vise would be nice, where I could like shift the angle of the board, which we do have elsewhere, but that's okay. We're gonna just try to like jury rig something here. But I could try to like get a little bit of solder in on this side to make sure that that pin flowed to the pad. But since we put, a bunch of solder on the pin, we filled this hole full of solder, and it's probably pretty reasonable to assume that it, totally filled and is making contact with the same pin through the hole. I'm not feeling too bad about it. What we could do is grab a multimeter and beep it out. Let's see. PCB. Yeah, there are a lot of tricks to making it clear which is pin 1 on a PCB silk screen, and I feel strongly that pretty much you have to denote pin 1 some way. Because the assembly house also, like if you're sending it out for assembly, they need to be able to double check that. And no matter how dense your circuit board is, you just have to mark which one is pin 1. Even though all that information should be contained within, all of essentially the metadata, right? But yeah, always having a visual check on that is good. Dots, lines, number 1, whatever. Yeah, outside of the pattern is good too. Yeah, I always try to put a dot outside of the pattern as well, so that once it's assembled and the chip is covering anything that's inside the footprint, that I can visually verify that, like, yes, there is the dot and there is the marking on the IC, and it's all good. Yeah. Yeah. Hello, Brent. How's it going? Yes, I could check so Brent makes a good point. It might not even be connected to anything in the circuit, but I think I'm going to grab a multimeter and just beep it out just to see. Multimeter pro tip, beeping stuff out. Always make sure that it's actually beeping before you beep something out. Don't want the battery to be dead or whatever. So I'm going to touch the bottom of the pad on this side. It's a little tricky. Got to kind of hold things just right. And actually, I'm going to do this one first because it's going to be easier to stick in there. So I'll do it on the top here. So this is a really good test because I'm sticking it in the socket, which is where the leg of the chip will go. And we do, in fact, have continuity. Yay! So yeah, like it is possible that it's like just touching and not really soldered, and like with board flex and stuff like that, you might get something intermittent. So it's something to keep an eye on. It's something to know that there's, maybe a little bit of weirdness about this. In fact, we might take a silver Sharpie and mark that just so we know we might remember to check it if something is being weird. Already making bleeps and bloops even though we're not finished. That's right. Oh, the tips on the probe. Yeah. So I am a fan of having at least one set of like precision probe tips because it just makes doing beeping out surface mount stuff and fine stuff like this like so much easier. So much easier. Otherwise, the probe tip, if you're trying to beep out like even a 603, like sometimes you just like you can't get in there, especially in a really dense board. But you do have to note that these wires are also super skinny, and they tend to, I mean, they're okay strain relieved there, but they do tend to get flaky after a while, sadly. So you do have to be a little bit more careful with those kind of probe test leads than the kind of typical style that like comes with them that are kind of like more burly. But yeah, all right. Are we putting the chip in yet, or are we finishing soldering the speaker and everything else? Speaker goes on next. Okay. Speaker. There is a plus and minus on the speaker, which we will line up to the plus and minus there. We will take it out of the vise because it's covering it right now. These leads I'm not going to bend. These are not good ones to bend. They probably go through and are attached to something on the other side. But since the speaker is tall and large and flat, you can just put it upside down on the table like this and solder it pretty easily. You can even kind of do, a third finger trick where, let's see, I don't want to do this. It's still a little funky, so I'm gonna like push down the board with that finger and then add solder over here. So I'm keeping the board like nice and flat. And before I'm soldering the other one, I'm double checking just to make sure the speaker is nice and flat, and it is. So there you go. So I didn't have to do like a tacking down thing on that because we added solder to the pin at the same, and like melted it with the iron at the same time. So it was a nice solder joint that was not cold. Okay, I have to admit, I'm totally kind of obsessed by this solder coil right now. I'm like, oh, can we slinky this? And I think I'm going to clip these leads off. And I'm really hoping that through all of that, plus stayed plus and minus stayed minus. I think so. I don't think I changed anything. I'm gonna like reflow this one solder joint because I'm not liking it. It looks like it's a little bit balled up like above the joint and hasn't really flowed well to the pad. So I'm gonna add more solder and more heat so that it flows. There we go. Yeah. Sometimes it's a little hard to tell with lead-free solder since it kind of goes cloudy and makes stuff look a little different. All right, potentiometers. Is this the last thing? I think this is these are the last parts to solder. Oh no, battery wire too. Cool. So potentiometers. So it's nice that these only go one way. We have the 3 pins right there, and then these two are probably connected. They might not be connected to anything actually, internally to the potentiometer, but they can be connected to like a board ground if you want to, and they're generally just going to be for mounting. So I'm going to make sure that the three leads are actually kind of like lined up first before putting it in, and then should be able to snap them in. And take a little more force. Woo, there we go. So slender DMM probe tips are good for surface mount, but buy 2+ sets as the wires will degrade over time. Yeah, I generally, like, basically if I have 2 sets, I'm going to be using them because I just like them better than the normal probe tips. But yeah, it's good to just know to like be know to check them. And if there's something weird, just double check and make sure that your probe, that your test leads are actually good. And then you can be assured that it's, your circuit or your board or something like that.
That's a good. Is there no volume?
Is there an amp speaker? The speaker is connected, I believe, directly to the GPIO. David uploaded a PDF of the schematic today. So let's see, there's a link to the GitHub repo. But yeah, like I didn't solder an amp on here, so there's no amp on here. So I believe it is just, directly off of a Atmega 328 pin. So yeah, it's probably not going to be super loud. And yeah, I don't think that the volume is adjustable in any way. I think it's just note tone, duration, and spacing. I'm just trying to see. The link is definitely, so this is the Dreamweaver 4N kit on the Cyber City Circuits site. And there are links, I think, off of the main product page to the, there we go, to the GitHub repo. So there we go. And let's see, view hardware. Oh, schematic was right there. Is it right here too? Maybe not. Let's go back. Schematic. Pretty sweet that like all this shit is accessible on your phone these days. Yeah, so we got speaker being driven through a 100 ohm resistor. And speaker, yeah, goes directly to D5. So yep. No amp, super simple. Yes, no volume pot. Yeah, continuity beep, yeah, is a good way to test probes. And yeah, always make sure if you're doing a continuity check, the first thing that you check is the probes. It also checks and makes sure that you like have a good battery in your multimeter too. That's happened a couple times. Why is this thing acting so weird? Oh, it needs a new battery. All right. Second one is in. Ooh, low power, low volume, low cost audio amp ICs. That's a good question. So Dan's asking if there's if any of us have favorite low power, low cost audio amp ICs. And I don't. I would be looking one up too. I haven't done much with audio. I'm kind of synth stupid. Like I think that they're super cool, but I haven't actually played with them very much, and I haven't really made, like, I think I've done one sort of like joke board that had audio in it, and it was also a speaker driven directly from an Arduino pin, and it didn't have an amp, and it wasn't very loud, and so I would be looking for that too. Oh, hey, David. No worries about being late. We're like, you're getting here right about at the good part. We're soldering in the pots right now, and we're about to test it out. I did have one little hiccup, which was that one of the pins on the socket broke off. It was kind of like bent, tweaked, and so when I tried to straighten it out, it just kind of snapped off. But, we just put it in anyway, filled the hole full of solder, and it seems to be making good connection, beeped it out. Not going to worry about it too much. Now that actually the schematic is up on my phone, I could probably see if that was indeed connected to anything. So let's see if I can figure out what pin it is. So we're going to count. Pin 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Pin 10. And if we look at, look at that. Pin 10 is blissfully free of anything. So, in fact, it did not matter. Brent was correct. So now we popped in all of those, and these are nice because they snap in so well. These are like big heavy parts, and they snap in so well that you can totally flip it upside down. Like I can shake this thing and they're like not moving at all. They're not wiggling in the least. So these are super nice to just put all in and solder all at once. All right. Let's see if I can get the whole thing in. There we go. All right. So these are all those big mounting holes. So a lot of times, especially for surface mount stuff, I will connect mounting holes to ground, and that is actually for mechanical stability. So this is especially true for small connectors, like especially freaking USB micro connectors that are surface mount. Surface mount micro USB connectors love to pry right off of the board after you use them for a while. I'm sure like pretty much everybody has had something where that's happened to them. And so what I like to do on my boards to try to help with that is connect the mounting tabs to ground, but I'll also connect them to ground without any thermal relief. And I do that because it provides a bigger mechanical area. If you have thermal reliefs around a pad, you're going to have like a channel around the pad and just like 4 skinny pieces of copper connecting that pad to the surrounding copper. So really when you have like a small connector and a big cable that can like cantilever that whole connector up, you're only connecting that connector to the circuit board via those 4 little skinny, ground relief traces, and those can just like pop right off. So if you just make it a solid ground plane in that area, that helps with mechanical stability and reliability. It does make it harder to solder, to hand solder. If you're, reflowing in an oven, then it's generally not a big deal as long as your profile is set up well so that, your whole board gets a nice heat soak and heats up and your solder flows on those pads. So yes, that's my tip and trick for laying out boards with tiny connectors that are going to get yanked a bunch. They're the expensive sockets too. They're not supposed to break. So honestly, it wasn't a problem with the socket. It was definitely that the pin was bent, and it was just the act of bending it back that broke it. And that just happens even with even though it was like shipped in the foam, which is very nice. I think that sometimes, especially the sockets, since they have fatter pins and they don't really have any like conicalness to it or pointiness to them, they can actually be harder to press into the foam than just a normal IC. And so sometimes I think the act of pressing that into the foam can actually like bend one over. So it's like, it's that thing that bites you in the ass, like, that thing that I was trying to do to protect this actually ended up like causing a problem. So yeah, I don't know, you might actually consider shipping the sockets outside of the foam, just by themselves. I think that they would hold up fine. All right, we got these 2 more to solder. Kevin's last phone had the micro USB fail. Yep, we've all had something. All had something with that. Yeah, no problem, Dan. I'm happy to share tips and tricks and things that I've learned over the years, for sure. You haven't found, so Dave at Cyber City says that he hasn't found a USB micro connector that he likes yet. You have a USB mini that you love. Yeah. So I really like the USB mini form factor. I think it's just burlier than the USB micro. It's easier to see which way it goes. It like is more rugged and reliable. Yeah, I'm not a big fan of the micro. I mean, obviously I understand why it exists because, you know, things are small and you know, that connector, you know, became comparatively big. But yeah, I think there's a real thing about making small connectors that are easy for people to use and also like rugged and reliable. And you know, that's why they went to the USB-C that can be plugged in either way. And I don't know, I don't have enough things with USB-C yet to know whether or not I like it better than the USB micro in terms of like reliability and longevity.
I feel like it lasts longer because you're not constantly like plugging it in upside down or like
trying to jam it in the wrong way. Yeah. All right. Well, dang, I think it is. I think it's pretty much entirely soldered. Let's see. Let's see, 6:20, an hour, 20 minutes, not too bad. I've been talking a lot, so, you know, I could have been going faster. Yeah. Ooh, there we go. Right side up. I like it. So I was just going on my phone to the instructions. The phone doesn't want to work right now, just to see if I'm missing anything or if I can just, oh, I guess I should solder the battery connector. So we'll do that. Plus to plus, minus to minus. This is probably the most important one to not screw up. And I am just sticking the wires through. Plus plus, minus minus. Come on. All right. And with these, I kind of do bend these over back towards the wire. Let's see if I can show you this on the scoposcope. Let's see. Where are we? We're there. So yeah, I hook them over like that, and that just provides a little bit more mechanical stability. So so that, you know, because these wires are probably going to be yanked and stuff like that, and yeah, just makes them stay in place a little bit better.
Was there one of the pots said that it looked like it wasn't soldered?
When it wasn't soldered? I'll check that in a second. Let me see. Let me just not get distracted and finish soldering these little battery leads. All right. Top left one. Let's see. So like this guy, or top left over here, right there. Let's see. Ooh, first one. Yeah. Let's see. I think we did miss one. Thank you. Thank you, Brent. Good eyes. Robin and I were talking about this last time, but it's like, it's a little weird. Like I'm soldering kind of at an angle here. Like usually I'm much more right over the circuit board, but if I did that, my head would be in the way and you wouldn't be able to see. So yeah, it's a little more challenging to do this stuff live. I think I might have missed that one too. Let me see. Come on. Thank you. All right. So those look good. Those look good. Looking at all of the joints, I think that's good. All right. So now we're going to put the chip in. Yay. So like, as I was saying before, a lot of times when you go to put a chip in, it, like, especially for super new chips that haven't been programmed or anything like that, the leads are, you know, splayed out a little bit more than the pattern will allow. And, you know, that is kind of the case on this one too. Like it's not gonna go perfectly in. And so what I do is I do the gentle bend. I use the body of the chip to sort of like as a guide to bend the pins in. So I take it up on its side like that, and I just very, very gently like press down and roll it just a little bit. And let's see. It's hard to tell. It's like it's hard to tell when you've actually, you know, kind of bent them or not. So I tend to just do like one side and then the other side, and then check it again. This looks better. It looks like that they're more at a 90-degree angle. Yeah. Oh yeah. That's fitting a lot nicer. And then sometimes, like, if you just have like one or two that are giving you trouble, but like basically, you know, like I think it was Dan brought up earlier, you know, if I just went like and tried to shove it in right now, like all the leads would bend and it would be bad. So like you just want to be gentle and careful at this step and really take pains to feel. And now I can feel that all of those pins are seated. You know, you just want to be wiggle, be gentle. I can feel that they're all lined up now in the hole. My notch is going to the notch. Very, very important. And now I can just press it the rest of the way in. Hopefully. Hopefully none are out. I don't think so. It's a little nerve-wracking, but there we go. And you know, it'll seat all the way. There are little shoulders on all of those pins, and so you can push it all the way down to those shoulders. So yeah, there we go. All right. I actually don't know. Hey David, is this guy pre-programmed? Like if I plug it in right now, will things happen? Will I get to make bleeps and bloops? Just freeing the battery from its plastic right now. Come on, battery, be free. Thank you.
Yes.
Yay! Awesome. Instant gratification. I love it. I love it. Because I was like, oh man, I don't know where my Arduino programming grad is. All right. So, you know what's a good idea? A good idea is to beep out power and ground before you plug something in. So, doing that. I think it's all right. And I'm just gonna beep them out like right here. Yeah, sounds good. No beeps. All right. Probably not going to short anything out. Sweet. All right. Plugging battery in. 9-volt batteries are polarized. Yay. Though it is possible to make contact. Ooh, something happened. Oh, hang on. Something's going to happen again because I'm really bad at plugging this in. There we go. Ooh. All right. I think D5 is our little power LED, and it is on. So that's exciting. It's doing something. Okay. Okay. Yeah, we're making noises. All right. So they probably all make the same noises right now because we haven't tuned them. So let's move a pot around. Ooh. Ah! This is entirely too much fun. Okay. Okay, we'll keep that one low. Maybe we'll do that one there.
Oh yeah, we're oscillating.
You're oscillating now. Yeah. I must say that I really like the LEDs too. Yeah.
Ooh.
Oh man, now I'm like getting a Super Mario vibe out of this. I don't know. We might need some new intro music to the, to the Wednesday solder sesh. It's in the key of C minor. That's awesome. I am musically stupid, so I never learned how to play anything as a child. So I don't really know. I don't know much about music, other than I like the way it sounds. That is awesome. That is super duper awesome. This is great fun, David. I'm excited about this.
That's so awesome.
Bowser's Dungeon vibes for a second. Yeah, right? Oh, all right. This was super fun. Definitely like worth. It's just like, oh god, okay. Ooh, I like that one. Groovin'. Like a kid at a birthday. Yeah, pretty much. I mean, this is delightful. This is super delightful to have something that you power up, make bleeps and bloops immediately, and also be able to like immediately interact with it and change it. Like that's pretty great. Good job, David. This is very satisfying kit. Very, very satisfying kit. And it's like, it's not, yeah, it's not loud. Sure, I guess it could be helped by like having an amplifier on it, but it's not too soft either. And I don't know, maybe it's a good thing that it's not too loud. If this was intended for kids and as a teaching thing, you might not. You might be driven crazy by it. But actually, like, my mom would totally be driven crazy by this. She has a special hatred of 8-bit noises, which I find very funny. And like, I was only allowed a Nintendo Game Boy as a kid, like when it first came out, and I wasn't ever allowed a Nintendo console. Boo-hoo. And I think most of that was because like she hated the 8-bit repetitive noises, and like most of the time she would make me like wear headphones with the Game Boy, which it just wasn't the same, man. It wasn't the same. Oh, cool. You like the idea of a custom track for the intros? Yes. Well, we're increasing our production quality every single time, or trying to at least. So, we're adding things here and there. You sell a Eurorack compatible standalone version with RGB LEDs. So yeah, I was recently asked if like I was familiar with Eurorack stuff, and I am not, and that is definitely something that I would like to get more familiar with. But man, like, dude, the synth rabbit hole is a big one, and it is a deep one, and I am kind of afraid to embark upon it because, oh man, you think I have a lot of projects now, right? Nice. So yes, in conclusion, boohoo. Yeah, this was a super awesome kit. It's available at Cyber City Circuits Dreamweaver 4N Junior. You could definitely, if you weren't talking, you could definitely put it together in an hour, no problem. I think that this would be a perfectly great first soldering kit for somebody. They might need like a little bit of, help here and there, and you know, help with like maybe pushing the trim pot or the rotary pots in, and like, you know, maybe help with the IC and stuff like that. But, you know, very, very good beginning soldering kit. And it is very joyous when it's done. So yes, this is the junior edition. So yes, it is pretty affordable. What was it? I forget off the top of my head how much it is. But I am going to look that up right now. Buy it now, $29.99, right? $30, and you can get your own little bleep bloop maker. So yeah, super fun. And yeah, so next time, I think I'm going to shake it up a little bit, and we're gonna do some soft circuit stuff. We're gonna sew some LEDs onto a bag. I got like a Watch Me Sparkle kit off of Adafruit, and it's like a unicorn with LEDs and stuff. And for those of you who don't know, I have a background with fiber as well, and I actually make and sell some tools for yarn dyers that they use in their process to help handle yarn and do some repetitive tasks with yarn management. And so I knit and I crochet and I spin yarn as well. I don't do that much embroidery really. I've done some cross stitch, and that might be another one that will start at a later one. I've had one of the Sweet Ohm cross stitch kits forever that I have not yet embarked upon. So that's a good one too. It has like the resistor color code. But the one next week it's super simple. You're basically like sewing some LEDs to a bag using conductive thread to attach it all. And I don't know, I think we'll be able to do it in about an hour and a half. We'll see. We'll at least be able to get one LED lit up in an hour and a half. So, and I'm probably gonna like shout out on some of my yarn based social channels for that. So if you want to do like some sewing and soft circuits, you don't really need too much. You can certainly get there are some kits out there. You could certainly get a kit, but you know, if you already have a bunch of electronics, like I think most of you might, really all you need is like a button sewing kit and conductive thread. And they also use a little bit of like conductive tape to attach the thread. Oh, and you also need, they use a double CR2032 battery holder that is sewable. So, so that you can like sew it to a bag. You don't necessarily, I mean, there are ways of attaching one to a bag. You don't necessarily need one that's sewable. If you have like one of the double holders, that's just, you know, that's just a normal one, that would be fine. But yeah, in order to attach the wires on it to the conductive thread, they kind of use this, this conductive tape to do that. And I think that you could probably actually kind of sew or wrap the thread directly to the wires, especially if you stripped them a little bit more. But if you don't have like conductive tape, but if you do, then that's great. So, and yeah, they're using the like self-flashing rainbow LEDs. So, you know, 2 leads, the ones that like color change. So yeah, not a lot of parts, and a lot of you might have most of them already in, you know, your box of stuff. So yeah, so the kit, it doesn't have an MCU at all. So it's just battery, basically the 2 batteries, to conductive thread, and sewing the LEDs. Bye. And yeah, and the LEDs are the ones with the built-in flashing pattern. So there's nothing needed to control them. They're just twinkly, colorful, twinkly, random. Yeah, just power switch LEDs, exactly. Yep. And I would like to do something though with something that has like one of the sewable MCUs, like maybe like a lily pad, or one of the Adafruit ones. I think like the Flora and Gemma are their sewable systems, I think. And I know that I have some of those in a box somewhere. And I actually have a box of like wearable stuff. So yeah, because that would be fun to do some like light up stuff, light up wearable stuff. Yeah, and it's just like basically a canvas tote bag. So if you have a canvas tote bag that already has like some sort of like cool graphic on it or something that you could like add some LEDs to and make even cooler, then yeah, then that's pretty much all you need. Awesome. Well, thank you guys so much for joining. It was awesome to have you all here and chat in the comments. And yeah, we'll just keep doing this and keep doing different projects every week. Thanks. See ya. Bye.